So good evening once again. Today we're going to medyo nahihirapan akong focus. We're going to have this lesson on introduction to multiple regression, and R is a very powerful software, guys, sa multiple regression. Once you get to know R, guys, once you get to know the functionalities of R, it will be very difficult to go back to Stata or to SPSS. Although syempre may mga inherent or intrinsic advantages yung mga softwares, whether it's Jamovi or SPSS or Stata. For me, there are far more benefits in using R compared to those other softwares. Okay, so as much as possible, guys, I made it a point in such a way that may mga outline to, no? Kasi hindi ko pa talaga na correct yung iba. So, tingnan nyo na lang, guys, if you can correct it on your own. Kasi di ba sabi natin, we'd like to need this, and so that yung output niya, whether it's an HTML notebook in our case, or HTML document, or a notebook, then we can easily take advantage of the output that's generated by RStudio. There are other, you can use other themes or other templates. May mga templates na iba. For example, let me just illustrate to you. If I open, for example, an R Markdown, okay, yun nyo guys, may template ako dito. No? I think you have also a template, kaso magkakaiba tayo sa contents. No? So for example, for instance, I like the template by Tufte. No? Si Tufte, very famous yan for data visualization. So ito example lang, Tufte handout HTML. Okay, you can get this by downloading the Tufte package. No? Tapos pag dinownload nyo na si Tufte package, lalabas niyan dito sa template. Okay, if I click this, it will generate a sample yeah. Okay, and then if we need this, parang R Markdown to, okay, parang R Markdown, pero ito created in a Tufte, yan, output Tufte from the package Tufte HTML. Okay, so if we need this, let me need that. Okay, it will ask kung saan isi-save. Dito ko isi-save sa projects natin, sa FIN, mali name. Okay, sample, Tufte sample, for example. Tufte sample. Let me just illustrate to you how a Tufte document looks like. So, i-generate dito yan. Okay, i-latex yan, ininit, no? Okay. So, walang mali. Mali ba? And then, sa formula, sample yun. Geom smooth using method. Tama naman. Okay, as we wait for the viewer, hindi pa tapos yung pag-meet niya. 37% pa lang. Kasi okay guys, medyo mababa yung energy ko ngayon. No? Kasi na, I'm not feeling well. Okay, it's taking some time. Okay, while we're waiting for that to meet, you can generate this, guys, by, there's a package called Tufte, and then you can load that. Let me see. Package Tufte. There, no? Tufte package. Tufte style for R Markdown documents. You can download that. Alam niyo naman mag-install ng packages, di ba? And once you have installed it, mag-open kayo ng panibagong R Markdown. And then instead of choosing yung document, you go to templates and then look for the tufte template. Yan, generate na siya. Okay, malapit na, 77. Almost done. Okay. So I think okay na. It should be in the viewer. Yeah, okay. So this is another example of an R Markdown, guys. However, making use of the tufte theme. Okay, saan na siya? Yeah, okay, tingnan nyo guys, no? Nice, no? Nice format, nice, you know, may mga ano dito, no? If you want a form like this na yung sabihin natin yung we call this, ang tawag dito, annotation or yung bibliography, footnotes, no? Nasa side, no? And then you can make comments here. Yan. Okay, so this is an example of a tufte style na output. Yung mga plots pwedeng dito sa side, no? Not necessarily sa ilalim kasi R Markdown natin sa ilalim binalagay yung ano. Ito, this is just a plot of empty cars. No? Okay, ito, no? You can see it in this format. Okay, you can write, of course, equations also. Okay, and you can occupy the whole page. Ito, full width na figure. Okay, so this is an example of a tufte output, an HTML output. And I like the style, guys. Kung informal lang naman, kung hindi, kasi sa research, hindi naman pwedeng ganito, no? It can be just an output, no? A document output, which gives us a different style of output. Then this is the way to go. This is an example. So maraming themes, guys, na which you can adapt in generating your R Markdown notebook or output. Okay, any questions so far, guys? Any questions about that?
Sir, administrative, paano ulit siya gawing default?
Yung which one?
Okay. As output.
Yung
di ba sir, parang kanina nasa settings, gagawin siyang instead of HTML, tufte yung gagamitin.
Okay. Dito, sige, pakita ko example. You will have to install first. Dapat install nyo muna, guys. Install that packages. No? Tapos si tufte.
Okay.
Yeah,
okay.
Okay. Tapos i-library nyo. Okay. Tapos once you have done that, you can now, pwede kayong mag-generate ng panibagong R Markdown there. Tapos, kasi dati ginagamit natin, di ba, si document, no? Si HTML or PDF. Ito, gamitin nyo si template. Okay, dyan. You will see now here, si tufte andi dito na.
Okay.
Letter T. Yan. Letter T. Tapos, ito, tufte handout. I-click nyo siya, and then mag-generate ng panibagong R Markdown na sample ng tufte, which is this one. Tufte sample.
Okay.
And then, cancel ko na. Ito na yun, no? And then you can knit this. Init mo na, ito nilalabas. No? You'll see. Tapos ito yung, of course, andito yung code kung paano nyo ginawa. No? So may konting nuances. Ito yung YAML na tinitingnan natin. Ano? May konting nuances siya on how to do it. Pero madali naman sundan, guys, kasi kung naiintindihan na natin yung R Markdown, ano na lang to, ito may mga dinadagdag lang na margin, no? For example, and it's not really difficult to follow kasi pag ninit na natin document, makikita naman natin kung what this looks like, itong code chunk na to. So I'm sure you'll be able to follow along. No problem.
Okay, sir. Next question, sir. Yung file na binigay niyo for today, we don't need to open it. Yung gamit yung tufte na.
No, hindi.
Okay.
Hindi. It's just a ano lang to, simple R Markdown lang to. No?
Okay, sir. Thank you.
Pero pag ninit nyo, kung gusto nyo in tufted, hindi siya, kasi wala naman tayong ginamit na ano na specific coding, na specific na pag-format in a tufted document, no? Kasi kunyari ang tufted, di ba, may mga ganito siya. May mga side, ano siya, side, yan, no? Mga side na ganyan. Di ba? So may specific na code dyan na, ayan, no? Kasi yung code nito. Okay? So if you follow this document, kung hahanapin natin yung specifically saan yung box plot array, hanapin na lang natin, tapos tingnan natin kung ano yung, dito yan, no? Ano yung specific code na ginawa niya in order to generate this plot on the side, no? Nasa side yung plot eh. So may specific na ano yan, na code na ginamit siya, and it's not really difficult, no? It's not difficult to follow. Okay, but I won't go there now. No? I won't go there now. I'll let you go through this, and just at least we are now having our eyes opened na hindi lang pala basta-basta si R Markdown, guys. Okay, maraming tutorials on R which is can be seen in the internet in the form of a book, no? As in book, complete chapter 1 to chapter 30. It's made in R Markdown with the help of a package called a book down. Okay, so you can actually create a book already using R Markdown. Okay, so marami siyang uses. Okay, so for today, guys, we're going to focus on a very important topic, which is the crux of our subject, applied regression. And we're first going to a very basic tone. I'm sure in your earlier statistics you have already met regression, but our focus will not be on simple linear regression. Bibigyan lang tayo isang example ng simple, and then punta na tayo sa multiple linear regression. Okay, so we know that a regression is a statistical technique. So the objective is to use our explanatory variables, our independent variables, in order to predict the outcome of an outcome variable or response variable or a dependent variable. Okay, so if you're using several variables in order to predict one dependent variable, then we call that multiple linear regression. However, let me just remind you that yung dependent variable, guys, dapat quantitative yan, no? Dapat continuous variable yan. Hindi pa pwedeng binary yan. No? Hindi pa pwedeng binary. Otherwise, the model will become a binary logistic regression. It cannot be also a character variable. So for example, you want to predict, guys, kung let's say kung ano yung religious belief ng isang tao given certain parameters, given certain independent variables. Eh kunyari, eating of pork, ganyan. So several reasons, and then you can predict kung ano yung pananampalataya or ano yung paniniwala ng tao as far as religion is concerned. Then you don't use multiple linear regression for that, no? Kahit na marami tayong independent variables. We use what we call a multinomial. No? Multinomial kasi yung dependent variable natin is a character variable or is a factor. No? Okay. Now, kapag dapat yung dependent variable natin, dapat quantitative, continuous variable siya in order for it to qualify as a multiple linear regression. Okay. So I hope that's clear, no? Now, as we mentioned a while ago, we'd like to establish the relationship, no? How good is a predictor variable in explaining your dependent variable? So you have the relationship between your explanatory and your response variable. Okay, ang method na ginagamit dito is what you learned in your stat as is your ordinary least squares. No? Okay, ordinary least squares. It's called ordinary least, LEAST squares, kasi when we use that model and to predict your response variable, we compare the predicted value with the actual value, okay? And so we have what we call the residual or the error term. Tapos, ini-square natin yung error term na yan. When we square the error term and sum it all up, okay, we will have the minimum value for that. So this is just like an optimization problem where we minimize yung error squared. Kaya nga least squares, no? We don't just add the errors, no? Kasi pag in-add natin yung errors, the sum will always be equal to 0. So we cannot generate anything out of that. That's why we use the least squares. Okay. Now, by way of review, guys, okay, take note of this, no? Ito, nakita nyo, guys, kasi yung next project nyo will be multiple linear regression. So dapat you should know how to write the equation in LaTeX format like this, no? So yung equation natin, y sub I is equal to beta null plus beta 1, xi sub 1, etc. hanggang beta null, beta n, x sub I n, plus your error term, epsilon sub I. So ito guys, we have n predictors and independent variables trying to explain your sole dependent variable. Again, the dependent variable should be continuous. No? Pag binary siya, yes or no lang, 0 or 1, then hindi na natin gagamitin yung multiple regression. Ang gagamitin na natin yung generalized linear model sa function sa R. No? Whereas pag ganito multiple regression, ginagamit natin yung LM function. Okay, so right, as we have defined, y sub I is your dependent variable, x sub I are your explanatory variables. Then your parameters, beta null, that's your intercept, constant term natin, beta sub 1 up to beta sub n are the slope coefficients for each of the explanatory variable, and epsilon sub I being the error term or the residual. Okay, am I right to assume, guys, that you have met this equation in your previous stat subjects? Pa-chat naman please. Na-meet nyo naman siguro to equation na to, no? Hello, guys. Don't be ashamed, guys, kung first time nyo lang na-meet, no? I'd like to temper my expectations. Kung first time lang naman, it's okay. No problem with that. No? Okay, so alam natin, guys, kapag linear regression, hanggang dito lang tayo, no? Hanggang dito. Beta 1, x sub I1. Tanggal na tong beta 2 hanggang beta sub n. Tapos matitira na lang din yung epsilon. So that's for the simple linear regression. But for a multiple linear regression, we know that that we have more than one explanatory variable. Okay, there are certain assumptions that we have to know, no? As far as the assumptions of multiple linear regression is concerned. Okay, there are yung iba, if you get a survey of different econometrics books, yung iba 8, yung iba 5, yung iba 6. Okay, so let's just use the most important ones for us. Okay, I'm not saying that the others are not important. Importante din siya, but for us the most important ones are these 6. Number 1, linearity of the data. So what do we mean by this? When we establish a multiple linear regression where we try to predict the value of your dependent variable using several independent variables, we have to the relationship between each of the independent variables on the dependent variable should be linear in nature. Okay, so dapat if you plot the let's say the independent variable on the y-axis and the dependent variable on the y-axis, if you plot it, if you do a scatter plot, then dapat makikita natin na may linear yung relationship. No? Kasi pag hindi linear, then it doesn't make sense to use a multiple linear regression unless we will transform the data. Kasi kunyari quadratic yan. So ang ibig sabihin ba nun, does that mean that we can no longer model your dependent variable, regress on your independent variable? Okay, using that kung quadratic yung relationship nila? Well, kung gano'n lang yung quadratic relationship, hindi na pwede kasi hindi magiging maganda yung model natin if we're trying to fit in and explain your response variable using a linear model. Hindi na maganda kasi ano yun eh, quadratic yung relationship nila. Most probably it will violate one of the some of the assumptions, no? One of which will be yung constant yung variance. Yung homoscedastic dapat yung residuals natin. Kasi if we're trying to model a quadratic relationship with a linear model, okay, chances are guys yung residuals yan magkakaroon ng pattern. Hindi na siya magiging constant. So that will violate our assumption. Okay, so dapat linear. No? Okay, for example, ito. We know that a quadratic expression is expressed by y is equal to a times x squared plus bx plus c. So if we're trying to force y to be modeled as c plus ax, then magmi-miss out tayo, parang hindi na fit yung model natin kasi nga may x squared component. No? Okay, using linear regression to model a quadratic relationship is not the best way to model that relationship. Okay, for example, dito nag-generate ako ng isang nagbigay ako ng isang example. Here guys, I'm creating a function. Now take note, sabi natin guys, dapat yung mga chunk natin, lagyan natin ng mga pangalan. And also it's good practice na huwag pagsasama-sama sa isang code chunk yung mga unrelated na mga codes. No? Okay, libre naman yung pag-create ng code chunk. So logically, i-separate nyo yung mga okay lang ipagsama kahit mahaba, basta logically linked sila. No? Okay, here we're creating an object called quadratic. Okay, and quadratic is a function. Well, in fact, we use the term function. So it's not a list, it's not a data frame, it's not a vector. Okay, it's not a matrix, it's a function. So there are objects like other than what we discussed before, di ba? Nag-discuss tayo ng vector, nag-discuss tayo ng list, nag-discuss tayo ng data frame, etc. So hindi natin diniscuss yung function. So here we're creating a function. Ang parameters niya x, a, b, c. And then open curly brackets. Then ito yung ginagamit natin, return. Okay, ibig sabihin generate a times x squared plus bx plus c. Okay, and then close brackets. Yun yung function natin. Okay, now we can ask R to solve what if a is equal to 1. So dinidefine natin kasi may mga variables tayo dito, a, b, c. No? A, what if b is equal to -2 and c is equal to -4. No? In other words, yung equation natin, 1 times x squared plus -2 times x plus -4. Yun ang equation natin. No? We defined a, b, c, and then we defined x to be, okay, x is equal to a sequence from -3 to 3 with a length of 100. Okay, let's print this outside, no? Para makita natin kung ano yung result. Oh, sorry. So copy this, tapos dito natin sa console i-run, no? Tanggalin ko na itong install natin, just Control V. Okay. Alright, take a look at this. X is equal to, it's a sequence from -3 to 3, and the length is length. Okay. Tingnan natin. I-print natin si X. Yung may X na tayo dito. No? It's a number from 1 to 1,000. Okay. Of course, we will have different answers. No? Different answers natin kasi. Yeah. So tingnan nyo guys, so how was this generated? It started with -3 kasi from, linagyan natin yung from -3 up to 3, okay, with the length equal to 100. Sorry, we will have the same answers pala kasi pareho yung ano natin, parehong simula, pareho din yung ending natin. Okay, from -3 to 3 and then 100 observations all in all. So, dinivide ni Aryan equally so that ito yung ma-generate na na figures. So si X natin guys, it's from -3 up to 3 and then 100 siya lahat. Okay, so we can now run this. Okay, kasi ito yung function natin, quadratic. Ito yung pangalan, di ba? Take note guys, run muna natin pala to. No? I'll run this first. Itong function muna natin. Okay, let's run the function first. Control Enter. Okay, and then take a look, guys. Dito, di ba? Values functions. Okay, so if you recall last time, data, pag data frame, values kapag if it's a vector. And then here now you have a new object here, function. Yung function natin is quadratic. All right, so you take quadratic function natin. If we supply a, x, b, and c, then it will perform this. It will perform this function and then generate the results. Okay, so from here, a, b, c, and then yung x nga, marami yan, di ba? 100 lahat yan. If we're going to run everything, okay, na ang x natin is from -3 to 3, tapos ang len niya 100, tanggalin muna natin to, guys, ha? Kasi inano ko lang from 1 to 10 lang, yung first 10 figures. If I remove that and then run this, kasi andito na yung function natin, quadratic. Sabi natin, quadratic x, a, b, c. Dinefine na natin kung sino si x. Dinefine na natin kung sino si a. Dinefine na natin kung sino si b. Dinefine na natin kung sino si c. So it will generate now 100 numbers, no? Kasi kukunin niya yung bawat isang number dun sa x and then isa-substitute na. Kunyari, 1 times -3 squared plus -2 times 3, -3 pala plus -4. No? So, ang x natin 100, di ba? So lahat yan guys, i-ano niya, i-substitute. No? So let's run a, b, c, x. Okay, control enter. Okay, there you are. 100 lahat yan, guys. Kasi 100 yung values ng x natin. Okay, i-check na natin yung dulong-dulo kung -1 nga ba. So let's just have a very quick check. So yun, 1 times, ano yung x natin sa dulo? Sorry, dito. Let me just check that here. Kasi yung value niya sa dulo, -1, no? Check natin. So, may equation natin. It's 1 times, yung a natin is 1, di ba? 1. Or actually, pwede natin a, kasi may a naman tayo, di ba? A times, okay. Kasi yung x marami, no? So yung huling x natin is 3, di ba? 3 squared. We're just testing kung tama nga na -1 yung answer. And then plus b times x. Ang x natin is 3. Okay? Plus c. Okay, plus c na, no? And plus c. And this will be evaluated kasi may object tayo na a, b, c. Okay, tapos yung x natin, in-specify natin na 3. Okay? And I expect to get -1 answer. Enter, yeah, -1. Okay? Questions, guys? Feel free to ask questions, guys. Simple na function lang naman yan. But you can create complex functions there. Complicated functions. Pwede natin gawin yan. But ito, just to give you an idea of what a function is. So, gagamitin natin dito yan. Okay. Any questions? Paki-chat naman please kung clear so far yung portion ng lesson na to. Okay, thank you. Okay. All right. I think only 2 answered. Lima ba? I hope the others were able to get it. Any questions? Okay, thank you. Thank you. All right, so let's take a look at this one. So I'm going to, where we are, guys, in the linearity of the data, di ba? Kasi sabi natin, yung first assumption ng multiple linear regression is that your dependent variable y should be linearly related to your independent variable. Okay, so let's take a look at this. Kunyari, guys, meron tayong ito. Let's create this plot. Okay, so I'm calling this R plot quadratic. And then I'm creating this object X. Sabi natin, di ba, pwedeng yung out minus. Okay? X is a sequence, this time from -10 to 10. 100 numbers yan. Of course, pwede natin gawing 1,000 yan. No? Yung length, 1,000. And then, ipapaplot natin si X. We're asking R to plot X. And then, ito, lalabas yung quadratic function. No? Okay, di ba? Ang X natin ito. So, 1,000 numbers yan. No? 1,000 numbers from -10 to 10. Okay, and then meron pa tayong ABC, andito pa yan. No? And then type is equal to line. So if this plot function will now plot your x-axis, okay, your x based on the values generated from this quadratic function, tapos line dapat. And then together with that, we will also plot a line, okay? H is equal to 0, horizontal line, color is equal to blue, and the length of the width is equal to 2. Is equal to 2, yung length ng width niya. Okay, so let's run this. Okay, there. Yeah, no? Yeah. This is the plot, no? So what was my intention in generating this plot? Ang intention ko, guys, ipakita sa inyo na kung ganito yung relationship na x at saka y, it doesn't make sense to, malamang guys, ang regression line nito, sabihin natin, maglagay pa ako dito ng no? H is equal to, let's say, sabihin natin kunyari, example lang to, 50. If 50 was the mean, no? Right? Let's suppose, guys, this is the regression line. If this was the regression line, what will happen, guys? Ang dami, yung mga errors siya, no? Talagang, if we plot the error terms, then it will create a very huge least squares, no? Okay, so, I'm just guessing kung yan yung, yun yung regression line. However, what my point was, guys, is that you do not model using a regression line. Hindi natin minamodel yung regression line. We do not use a linear regression line if the relationship between your variables, your x and your y, is quadratic. Or if it's polynomial, kunyari marami siyang maxima at saka minima, pag polynomial siya, then it doesn't make sense, guys, to use multiple linear regression. We will be stretched, guys, to use that. That will require other modeling techniques, hindi multiple linear regression. Okay, so I hope that's clear, guys. Ang unang-unang assumption, dapat yung linearity of your data. Second, linearity of the parameters. So kanina, linear yung data natin, yung relationship nila. Pangalawa, linear dapat yung parameters. What do we mean by this? Okay, so let me just read this. Assumption 2 requires that the specified model to be linear in the parameters. What do we mean by parameters? Yung parameters, guys, yung mga slopes natin. Ito, guys, yung mga beta 1, beta 2, beta 3, beta n, yun yung mga parameters natin. So what do you mean by linear in parameters? Okay, it means that hindi ko na siya to. Okay, take a look at this, guys. So let's assume this is your regression model. Beta null plus beta 1 squared times x1 plus beta 2 times x1 2 hanggang beta n. Now take note that your parameter beta 1 is squared. So hindi siya linear. Okay? So it will be next to impossible. It will be very difficult to compute for your beta. In this case, yung beta squared na to. Kasi hindi siya linear. Kasi naka-squared siya, naka-quadratic, no? So what does this assumption tell us? Yung assumption 2 ng classical linear regression model requires the model to be linear in parameters. No? Hindi pwedeng naka-square root si beta. Hindi pwedeng naka-log si beta. Hindi pa pwedeng naka-1 over beta. Okay? Hindi pa pwedeng naka-beta to the nth power. Okay? So I hope that's clear. Now it doesn't mean that take a look at this. Now si x naka-square dito, no? Tapos dito regular lang siya. So whether si x naka-squared or naka-log or naka-1 over x or naka-square root, no? Whatever form x has, whatever structural form x has, it doesn't matter. Okay lang yun, guys. Okay? So no problem when your x is squared or cubed or square root or exponentiated or log. No problem. Okay? Pero hindi pa pwede, guys, yung ang beta yung nakaano. Okay, ininit ko lang to, guys, sa sana malumabas yung image dito. Since you don't have the image, just don't knit it. Ako lang mag-knit, no? Gusto ko lang makita yung nag-knit dito sa ano. Okay, I want to show this to you. Okay, itong image na to. Okay, it's rendering. Okay, just to reinforce yung sinasabi ko dito, guys, na yung distinction between linear in parameters and linear in your 202. Sandali, check ko lang itong 202. Ano itong 202, error in 202. Kasi may mga hindi pa ako na double check dito. Ito. Okay. Okay, let me just ano ko lang to, guys, i-hashtag ko lang siya. Kasi mga errors yan, no? May mag-errors dito. So init ko lang ulit. Kasi pag yung code natin may mga errors, hindi siya mag-proceed. Okay, ito nag-run na, yung na-view natin yung mamaya to sa wage. Okay, ito yung data. Okay, so mukhang okay na siya. I'm just deleting it first. I'll send na lang, guys, yung mga image dito, no? Okay, nag-minute pa siya. Okay, 233. Sandali, last na to. 233, baka meron pang iba. 233, delete ko na lang to, May mga functions na hindi pa na 233, where's 233? Okay, bakit? Plot. Not found. Not found. Guys, sandali lang, kasi hindi ko in-attach dun sa ano. Wage, education wage, hourly wage. Okay. So let me just first, para lang mag-run to, no? It should have run already. Okay. Okay, rinan ko lang tong wage. Okay. So, need ko ulit. I'm expecting this to run. Okay. Sorry, guys. Okay, tanggalin ko na lang muna itong tanggalin ko muna itong code chunk na to. Hindi ko na muna ipaparan to. Okay, para mag-knit lang siya. Nagkaka-error dito. I wonder why. Okay. Last na to guys, okay lang ba? Last na to. Pag wala pa rin to, itong 254 na to, then I'll 254. So, object not found. Okay, sige, tanggalin ko na rin to. Alam ko naman kung ano yung mga tinanggal ko. Yan, sige. Tinanggal ko na, hindi na siya code siya, no? Parang text na lang siya. Para lang mag-neat. Kasi gusto ko lang naman pakita yung mga images doon just to reinforce what we were sana okay na. Huwag ka nang mag 271. Ano naman siya? Tanggal ulit siya. Huwag nyo gagawin yan po guys kasi babalikan naman natin yan. We're going to nag-error lang yung si GG45. I don't know why. Sorry for the repetitive. I think okay na to, no? Kasi hanggang doon na yung ano eh. Where's my R? Yan, okay na. Almost done. Huh? Ay, kaya na. Could not fetch images. Okay, anyway guys. Anyway, yung image yan guys, equation lang yan. No? Equation lang yan ng ano, ng pakita ko naman. Doon ka na sa image mismo natin. Okay, so it was supposed to be this image, no? Diretso ko na munang pakita sa inyo. So ang tagal mag-engage ng JPEG. Okay, so this is just an image. This is an equation, guys, na it shows the meaning of linear in parameters. As I mentioned a while ago, pag sinabing linear in parameters, yung mga slopes, yung mga betas ang hindi pwedeng hindi pwedeng non-linear. Pero yung mga values ng independent variable, it can be log, it can be square rooted, it can be whatever, no? Whatever yan, no? So if we take a look at this equation, y is equal to beta 1 times square root of x1. Pwede yan. Beta 2 times log of x2, pwede yan. Squared, ito, pwede rin to guys. Kahit i-multiply mo yung x1 and x2, pwede yan. This is what we call interaction. Okay, so pwede, itong mga interaction na to where we multiply x1 and x2 and we square x2 where we get the log, that is okay. That is acceptable. Pero, yung beta mismo ang naka-square root, naka-log, hindi pa pwede. Okay? Alright, so that takes care of the second assumption. Third assumption, guys. So
Sir,
yes?
Can I ask a question, sir?
Sure.
Yung linearity ng parameters, sir, do we decide that when we do it, or do we have to check our data to check if our parameters are linear?
Hindi, kasi ano naman pag ginamit mo yung LM function, kunyari, ang assumption na yan, yung parameters na pinapasolve mo linear. Magkakaproblema lang yan kung in-impose mo na, kunyari, beta 1 should be squared, no? Yun ang magkakaproblema. Pero pag ordinary lang na regression, kasi gagamitin natin yung function na LM, okay, which I'm going to show you in a while, walang problema doon, okay? So that's a very good question. Thank you so much for that, no? So don't worry guys kung minomodel natin yung dependent variable natin on several independent variables. Hindi naman tayo pwede magkamali doon na non-linear yung parameters natin na data kung ginagamit lang natin yung LM function. Okay? So no need to worry about that. Pero kasi baka there might be some instances na i-impose natin na si beta 1 dapat squared. Doon na magkakamali. Okay, kasi we can do that, no? But generally guys, pag ginamit lang natin yung regular na multiple regression function ni R, hindi tayo magkakamali doon. Okay? Did that answer your question?
Yes, sir. Thank you, sir.
Thank you. Thank you. Okay, thank you, Ina, no? Si Ina ba yung nagtanong? Sorry, hindi ko pa kabisado yung voices nyo.
Yes, sir. Ina, sir.
Ina, thank you. It will take some time for me to to really memorize your voices. No? Kasi once a week lang tayo nagkikita. Eh. Okay, third guys, homogeneity of residuals variance. Ano ibig sabihin nito? Di ba pag gumawa tayo ng model, when we have this model, pag sinabi natin may model tayo, may mga values na yung mga betas natin. Okay, so pag may mga estimated values na, and assuming they're significant, we now have an equation. And when we have that equation, we can now predict the value of your y, the value of your dependent variable, given the values of your independent variable. So magkakaroon tayo ng predicted value. Okay, so let me show you again the equation. Sa plot na lang natin. Ito, no? Okay, suppose guys, na-predict na natin si beta 1, beta 2 hanggang beta p. Okay, so since we know the value of for a particular observation, no? Alam natin yung value ng x1, alam natin yung value ng x2 hanggang xp, no? Tapos guys, isa-substitute natin dito yung sa equation na to. Okay, we know the values of beta 1, beta 2 hanggang beta p. Based on that, magkakaroon tayo ng predicted value of y. And then, usually, more often than not, the predicted value of y will not be equal to the actual value of y. So yung deviation niya, yung difference niya, okay, it's called your residual. Yun. Ito yun. Okay, it's called your residual. Then when we plot the residuals, guys, okay, so there are several ways to check for the homogeneity. Pag plinat natin, for example, yung predicted y sa residual squared or sa residual lang, dapat guys, yung ano niya, pag plinat natin, dapat constant siya. So what do you mean by constant? Okay, itong image na to, it should have been this one. So pakita ko lang ulit, this one. Okay, take a look at this. Can you see guys the diagram?
Yes, sir.
Okay, thank you. No? So I'm sure you have met this diagram before. No? So ito, makikita natin na residuals. So we're plotting, let's say, yung residual squared divided to the predicted value ng y. No? If the residuals behave this way, so there's what we call a fanning out. Parang paypay siya, no? Nagfa-fan out siya. The fanning in naman, papasok. No? Then we say that this, notice, at a particular value of your x-axis, whether it's the residual squared, no? Kunyari dito, manonotice natin guys na yung variance niya ito. Pero at this point, no? At this point yung variance niya itong height na to. At this point, konti lang yung variance niya. So the variance is not constant, no? Pag hindi constant yung variance, we call that a heteroscedastic residuals. Yung distribution of residuals is heteroscedastic. Then compare that guys with this one. Kahit sa anong value ka ng residual pumunta, no? Ito pa rin yung variance niya. At this point, ito pa rin yung variance niya. So constant over time. So if the residuals behave, display a constant variance over the values of your x, guys, then we call it homoscedastic. And this is what we want. We don't want this. We don't want this. Kasi pag may heteroscedastic yung mga variance natin, mga error terms natin, then that might mean that our estimates, yung mga parameters natin are biased. No? So hindi pa pwede yun kasi dapat magkaroon tayo ng, we'll explain next time yung blue, no? Have you heard of blue, guys? BLUE? Chat nga please if you have heard of that in your prior stat. Blue, guys, narinig nyo na yun? Okay, answer. No, okay. Blue, guys, means, dito ko susulat siya. Sa console na lang. No? So dapat, ang hinahabol natin yung blue na model natin, no? Which is best linear nakalimutan ko yung sorry guys, basta blue yan, i-ano natin, no? I-ano natin next time. Best Sorry, unbiased, no? Okay, thank you. Best linear unbiased estimators. Ito yung kailangan natin, guys. Na yung estimators natin, yung parameters natin, yung betas natin, dapat it's the best for our given the data. It's linear, it's unbiased, okay? Estimators. Okay, and we will have the blue. We will have a condition of our model called blue if it does not violate the assumptions. No? So kapag na-violate yung homogeneity ng residual variance, then hindi na siya unbiased. Okay, so these are the things that we would like to have. Okay, yung blue natin na na model. Okay, number 4, guys, multi-collinearity. Okay, so saan naman to? Ano ibig sabihin ng multi-collinearity? Ang ibig sabihin ng multi-collinearity, guys, yung independent variables natin are not highly correlated. Okay, remember, yung mga explanatory variables natin, yung independent variables natin, we use them in order to explain your explanatory variable, your response variable, your outcome variable, si X, si Y. Ngayon, kung related yung x's natin, yung mga independent variables natin, parang mag-aagawan sila in explaining your dependent variable. Okay? So what do you mean by multi-collinearity? It refers to the condition in which two or more predictors are highly correlated with one another. So we don't want that. We don't want that our predictors are highly correlated. Gusto natin highly correlated si Y, yung dependent variable, at saka si X. Yun ang gusto natin. Highly correlated si dependent at saka si independent. But we don't want the independent variables to be highly correlated. Okay, magkakaproblema tayo dyan. Okay, so let me go back here and sinabi natin dito. This is a problem as it can be hard to disentangle. No? Which of them best explains any shared variance with the outcome variable? So ilang percent ng variable x1 ang ilang percent ng variance ni y ang ina-explain ni x1, ilan ni x2, highly correlated sila. So it becomes very difficult to disentangle the effect of these variables on your y kasi nga highly correlated sila. Kunyari sa x1, guys, example lang to 1, 2, 3, 4, 5, 6, 7 hanggang 100. Tapos si X2, 5, 10, 15, 20, 25 hanggang 500. Okay, so ano relationship ng dalawang yun? Well, they're perfectly correlated. Kasi X2 is generated by multiplying X1 by 5. Okay, so when we use them, X1 and X2 as predictors of Y1, magkakaproblema tayo. Okay, we will have a problem because they are perfectly correlated. Okay, it means, guys, that bakit gagamitin mo pa yung dalawa? Pwede namang isa na lang gamitin mo kasi pareho lang naman silang ina-explain on your dependent variable. Okay? So that's what we mean by multi-collinearity. We don't want the variables, the independent variables, to be highly correlated. Ayaw natin yun. Gusto natin si dependent at saka si independent, highly correlated. Okay, so sabi nga natin dito, the two correlated independent variables may actually represent the same underlying factor. So in a regression context, this multi-collinearity can make it difficult to determine the effect of each predictor on the responses, as we said a while ago. Okay, and can make it challenging to determine which variables to include in the model. Okay, multi-collinearity can also cause some problems. So yung coefficients natin, yung mga parameters natin, poorly estimated or inflated. Okay, the coefficients might have signs that don't make sense. Like, kunyari, no, sa health, no, alam natin na yung let's say, kunyari, ano ba maganda example? Okay, it skipped me now, no? Pero may mga variables, kunyari, guys, na na highly correlated sila. Tapos yung isa, positively correlated dun sa response variable. Tapos yung isa naman, negative. It doesn't make sense, no? Doesn't make sense. Kunyari, si GNP at saka si GDP. Bine-regress natin yung isang economic variable kay GNP at saka kay GDP. Eh, related yung dalawang yan, di ba? Some factors lang yung may iba dyan. Pero what if it turns out that your beta is positive for GNP and your beta is negative for GDP? Okay, so that can cause us to, bakit ganun? Di ba? It doesn't make sense why GNP is positive, GDP is negative. Okay, so that could mean that your variables are collinear. So that's what we call multi-collinearity, and we don't want that. The standard errors for these coefficients might be inflated. So we're going to learn how to deal with that, guys. Let me just show an example. I think meron ako dito. Lining ko yata, hindi ko nalink. Okay, tingnan nyo to, guys. Okay, here, ano ba yung, okay, here we created a scatter plot. Okay, this is a correlation plot between weight, height, and BMI. Okay, si weight, si height, si BMI. Yung diagonals dito, okay, this is the correlation of the variable with itself. Siyempre, weight with weight, height with height, and BMI with BMI. But if you take a look at the correlation between weight and BMI, it's very high, 0.86. And then, si height at saka si weight, hindi masyado kasi hindi naman siya ganun ka, kasi may mga tao na matatangkad, guys, pero yung weight naman nila, hindi naman ganun kataasan. May mga tao, so it doesn't matter that if you have a very high height, mataas yung height mo, it doesn't matter na yung weight mo mataas din. It's not like that. May mga tao na napakatangkad pero ang payat. Merong mga tao din na napaka maliit pero malaki sila. And may mga tao din na matatangkad pero napakalaki ng weight. So we cannot really say that the higher the weight, the higher will be the higher the height, the higher the weight. Pero itong BMI, guys, kasi si BMI, how do you compute for that? BMI is computed using the weight. No? So if you take a look at weight and BMI, ang taas niya, 0.86. And then on the other hand, si height naman at saka si BMI and height, okay, 0.02, wala. Very weak relationship ni height and BMI, 0.02. Okay, pero si weight at saka si BMI, very high. No? So this, if you're going to use this, both weight and BMI as predictors, okay, let's see, I think I have the results here. Generate akong results dito. Saan na siya? Ay, hindi ko na save, sorry. Sayang, hindi ko na save. So, sana pakita yun. Yung regression output. Okay, bale. Next time papakita ko, guys, na nagkaroon ng very, very weird na result yung regression. Okay, weird na result yung regression. If weight and BMI are highly correlated, kung highly correlated sila, positive pa, di ba? So, ano bang variable yung ginamit dito para I forgot the variable, the response variable, the independent variable. Pero it turned out, guys, that si weight positive, then si BMI negative yung beta. So, how can that happen? Yung relationship nila, guys, very strong positive relationship. So, dapat yung effect din nila dun sa response variable, well, to be positive or negative, pero dapat pareho sila. Ang nangyari dun sa regression output, guys, yung isa positive, yung isa negative. So there's something wrong. So that's what happens, guys, when you have multi-collinearity, when you have strong correlation between your independent variables. Okay, sige. Tuloy tayo, guys. Let's continue. Fifth, independence of residual error terms. So, independence, what do you mean by independence of residual error terms? Ibig sabihin, kunyari si residual epsilon sub 1, dapat hindi siya related kay epsilon sub 2. Epsilon sub 2, hindi siya related kay epsilon sub 3, etc. Okay, so di ba may data tayo, di ba? Tapos each of the responses there, each of the observations there will have their own residuals. So sabihin natin sa observation number 1, may residual siya. Sa observation number 2, may residual din siya. Sa observation 3, ganun din. Dapat, yung mga residuals niya, dapat hindi siya, they should be independent of each other. Okay, now this is more true if it's, pag cross-sectional data, guys, hindi siya masyadong problema. Kasi pag cross-sectional data, pwede mong baguhin yung order ng data na yan. Unlike pag time series, guys, talagang specific yung time series na hindi natin pwedeng baguhin yung, kunyari, 1970, and then 1971, and then 1972. Hindi natin pwede unahin si 2010. Tapos jump tayo kay 1980. Tapos 1999. Hindi pa pwedeng ganun. Hindi pa pwedeng randomly natin i-rearrange yung data natin. It has to have may strict na sequencing, no, yung time series 1970, 71, 72 hanggang 2020 kunyari, no? So there might be a chance that the error terms are dependent of each other. So may dependency yung mga residuals ng error terms, and that happens oftentimes sa time series, but not in a cross-sectional data. By the way, guys, what's the difference between a cross-sectional data and a time series? Can anyone explain, please? Anong difference sila? So we should know that, guys. By heart, we should know that. Okay. Cross-sectional data, ano to? Ilang units to?
Try lang, sir.
Okay.
For cross-sectional, usually comparison yan ng, let's say, magkaibang company.
Okay.
No?
Okay.
For time series, normally that's same company pero over different time periods.
Okay, thank you, Richard. You're correct, no? So as Richard said, ang cross-sectional data, guys, you're looking at several units. So yung unit na yan, pwedeng yung company. So you're studying different companies or different countries, different continents, different individuals. So yun ang unit natin, unit of study natin. Ano ba yung pinag-aaralan natin? Are these companies? Okay. Are there many companies being studied? Kung several units or several individuals, we can call it individuals, and a time frame is equal to 1. Pag iisa lang yung time frame, kunyari 1980 lang, no? So you have, let's say you're studying macroeconomic factors ng several countries across the globe, no? So you have, let's say, 100 countries, and then you're looking at GDP, GNP, unemployment rate, mortality rate, etc. No? And then all taken at a snapshot, 2020 lang. That's an example of a cross-sectional data. On the other hand, guys, pag time series data, you have a single unit, no? Single unit, and then set time frame nito is equal to many. No? Okay, example, guys. Okay, tingnan natin, single unit, Philippines lang kunyari, no? Philippines, tinitingnan natin yung GNP niya, GDP, same macroeconomic environment, no? Like macroeconomic factors. And then you have data from 1970, 71, 72, 73, 74. Okay? So that's what we call a time series data. Okay? And then lastly, guys, we have what we call a panel data. So si panel data, guys, combo to, combination of cross-sectional and time series. Example, balikan natin si Philippines, no? Example natin kanina na time series. Okay, hindi, gawin natin na yung kanina, yung several countries, no? Several countries, 1970 lang. Gawin natin several countries, yung units yung tinitingnan natin, pero 1970, 1971, 1972, 1973, etc. hanggang 2020. that now is a panel data. Okay, it's more complicated to analyze that, but we're going to towards the end, guys, magpa-panel data analysis tayo, no? So ito yung tatlong types ng data na pwede natin makita: cross-sectional, okay, several units. It's important to define kung ano yung unit mo, no? Are these the firms? Are these companies? Are these individuals? Are these countries? Okay, so dapat ma-define natin kung ano yung units natin. So several units, isa lang yung time frame. Okay, 2020 lang, Philippines lang. Tinitingnan natin yung mga GNP, GDP, etc. Cross-sectional data lang yun. Okay, pero gawin natin, several countries pala, no? Several countries: Philippines, Singapore, Malaysia, Indonesia, Thailand, Vietnam, etc. ASEAN, no? ASEAN. Tapos pininala natin 2020 lang. So cross-sectional yan. Pero gawin natin nga, guys, ngayon, Philippines lang. Pero 1970 hanggang 2020. Time series yan. Kasi ang unit of focus natin is the country, so Philippines lang. Several units of focus, several time frames, that's your panel data. Okay? So itong independence of residual error terms, guys, mas nagiging relevant lang siya for a time series or a panel data. Not so much for a cross-sectional data. Okay? All right. So lastly, guys, yung normality ng residuals. Okay, we will plot this next time. Papatingin natin, guys, kung ano mangyayari kung yung residuals natin not normally distributed. And we will see what are the implications. No? What will happen to your blue, yung best linear unbiased estimator. Okay, so in a nutshell, guys, ito yung mga assumptions natin ng multiple linear regression. And you have here, I gave you, this is a good reference, a good resource. Okay, you may look at this. And then marami, guys, marami pang marami pang resources, marami pang references which you can look into. Do not be limited to just one reference na binibigay ko. Ang dami kasi, kaya I just give one example, and then it's up to you really as responsible master students to dig deeper and see what are the implications kung na-violate yung ano natin, yung assumptions natin ng classical linear regression model. Okay. Now, before we go into regression, guys, importante na there are two things that you need to do even before you start analyzing your data and doing multiple regression. Number one is visualize your data. So, i-plot nyo yung data. So, in the course of this subject, we're going to learn how to plot yung mga data natin using ggplot2. So, since we will not really have time to spend mga 2 weeks looking at ggplot2, I strongly urge you guys to view, watch videos on ggplot2 para may working knowledge kayo. So that when we use ggplot2 in our classes, then aware kayo kung ano nangyayari doon. No? ggplot2 stands for Grammar of Graphics. No? ggplot, the package was developed in 2005, okay, by Hadley Wickham. No? Siya yung nag-develop nun. Sulat ko lang, Hadley Wickham, 2005. Yung first version ng ggplot2. Ngayon marami ng versions eh. As of June 2021, version 3.1 na yata. So it has evolved over the time. It has become really more powerful. Pero yung ginamit dito sa ggplot2, this is the package. Plot2. Okay, GG means GG is equal to, ibig sabihin yan, guys, Grammar of Graphics. Okay? Grammar of Graphics. And ggplot, yung Grammar of Graphics, was developed by Leland Wilkinson. Okay? Famous na nag-develop ng GG, ng Grammar of Graphics. Ang difference ng Grammar of Graphics, guys, is that it compartmentalizes your plot. So layering siya, layer. Kaya madaling guys, madaling gumawa. Kasi ile-layer mo yung data, ile-layer mo yung aesthetics, yung x-axis, ano yung y-axis. Doon sa aesthetics yan, pwede mo lagyan ng kulay, pwede mo lagyan ng formatting. i-layer mo rin yung shape. So is this a histogram? Is this a smooth line? Is this a box plot? Okay, so ganun guys yung grammar of graphics. So it's intuitive. At the onset, yung learning curve nito, medyo mataas-taas din. No? But once you get the hang of it, madali na, and then ma-familiarize kayo guys, you'll be happy that you learned yung GG plot 2 na to. No? Grammar of graphics. Okay. Now, aside from dapat bini-visualize natin yung data natin, okay, kailangan din natin guys mag-descriptive statistics because this will also explain to us yung behavior ng data natin. Okay, remember this is data analysis. Okay, pangatlong step na guys yung statistical analysis natin, whether it's a regression or we're doing a random forest or we're doing a supervised learning or unsupervised learning, etc., etc., etc. Before that, i-plot muna natin data natin, tingnan natin. Tapos, tingnan din natin guys yung descriptive statistics. No? So here guys, hindi na natin masyadong titingnan kung ano ibig sabihin ng skewness or kurtosis or mean or yung 5 number summaries na quartile 1, quartile 2, quartile 3, quartile 4, etc. guys. Bahala na kayo doon. No? I will hold you responsible for that. Okay, so there are several packages that we can use in order to generate descriptive statistics. These are just some of them, no? Yung 4 na to. So, since malamang hindi nyo pa na-install yan, kailangan guys, install nyo muna. So, you know how to install naman, di ba? So, install that packages. Dapat small letters. Install that packages. Okay? Tapos, since marami siya, pwede naman natin i-combine yun. C, then open parenthesis. C, and then, ano yun? Si HMIS, si Psych, si Stargazer. Okay. Okay guys, kasi most probably guys, hindi nyo pa na-install to, no? So HMIS. Okay, comma. Sino pa? Si Psych package. Comma. Sino pa? Si SchemR. Okay, SchemR. Comma. Si, ano pa? Si PasteText. PasteText. And then comma. Ito si Stargazer, hindi naman talaga siya ano. It's more of creating tables lang. Magandang tables. Alright. So I will not run this anymore guys kasi na-run ko na to. No? Naka-available na yung package na to sa machine ko. Now remember guys, you install only a package once. Okay, but every time you're going to need the functionality of that package, you have to load it. Yung library or require. Sabi natin, di ba? Or require. Ayan, require. HMIS. No quotes. Ayan. So, pareho lang yan guys. Library or require. Okay, I'll give you a few minutes, 1 or 2, to load this guys, to install the packages, and then to require the packages. And then please chat guys kung natapos nyo na. If you're able to install and then load the packages. Okay, ipo-pause recording ko guys. Kindly remind me guys na baka makalimutan ko. Okay, now that we have downloaded these packages and required it, ibig sabihin guys, any functionality of these packages we can already use. Now, ang suggestion ko guys, medyo hanapin nyo rin to, no? Yung documentation nila. Okay? Do on your own, ano ba yung ginagawa ng HMIS? Si site package, si SchemR. Okay? You know how to find this? Pwede nyo namang hanapin yan sa Google yung documentation yan. No? Ano yung mga functions yan? Ano yung mga codes na pwede natin gawin dyan, gamitin in order to help us with our analysis. Okay, so first guys, let's remember that before we said that R comes with several packages which we can install, and it also comes with several data sets. So let's run this kung data na to, na function na to. Okay, yung data function will give us ito, no? It will tell us ano yung mga data sets that come with R. So marami yan. Okay, so many data sets And then maybe yung iba sa inyo wala pa no nang nakalagay dito kasi I'm not so sure no if we have the same kasi some data sets come with packages. So if there are packages that I have already installed which you have not yet installed, so it might not be found here. Okay? But anyway, guys, as I said, maraming katulad ng air passengers, no? Okay, let's just have an example. If data, if I just run this, ako sa class ko ginagamit ko tong air passengers sa data visualization. Not air passengers. NYC pala, sorry. Air passengers pang time series yan. Let's see, NYC flights, New York City. Wala. Why wala? Why not here? And then NYC flights, no? Let me check once. Okay, hindi. Hindi yung data na NYC flights. Okay, anyway. Yun na lang, yung si air passengers, which oftentimes is used in time series analysis. Yeah, no, guys, no? So if you plot air passengers, right? Yeah, okay. Kita nyo, time series to guys, no? And it makes sense to use a time line graph for this. Pag cross-sectional guys, hindi tayo gumagamit ng line. Kasi wala namang rhyme or reason yung sequencing nila. Pwedeng mabalik-baliktad yun. If you're dealing with countries, for example, pwedeng alphabetical yun or pwedeng random lang, di ba? So it doesn't make sense to use a line plot for a cross-sectional data. Ginagamit guys yung line plot para sa isang time series. Okay, so enough with that example. Just to show you that there are available data sets in R, and some of them we're going to make use of. All right, Tito guys, kindly upload the wage data set which I shared with you sa Canvas. Now, how do you upload a file? How do you upload a file in R? Okay, there are several ways to do this, but one of the easiest way is this one. Import dataset. Kung hindi nyo kabisado guys yung mga code na read_CSV, yung mga ganito, no? What you can do is to manualize it first. Here in the environment, you have import dataset. So let's click this, and then we can use base R or yung mas powerful na read R if you're using a text, whether it's CSV. Okay, so we can use this if it's Excel, from Excel, SPSS, SAS, or Stata. So there are different data types that we can import. Okay, so gamitin natin itong read R. So if I click that, guys, and then andito yung browse, no? So syempre, ilagay nyo guys kung saan nyo sinave yung wage na dataset. I hope you saved it in your working directory. Hindi pala natin tinignan yung working directory, no? It's good practice always to look at your working directory, get working directory, and set working directory. Doon natin ilagay dun sa project folder natin. Okay, so look for its site, guys. Hanapin nyo yung i-browse nyo, and then pwede yung lagyan ng pangalan. Kasi pag clinic nyo to, may pangalan na yun, guys, no? Ang pangalan niya wage, automatic na yun maglalagay. Unless you change the name. Okay, and then it's a comma-separated file. And then lalabas dito guys yung code. Okay, lalabas dito yung code that you could have used in order to upload that file. Okay, so ito, no? Ang lalabas dyan, since ginawa ko na kanina, no? After I imported it, guys, paki-import nyo, lalabas dito yung code, no? Sa console, lalabas yung code. Okay? Pag lumabas yung code dyan, guys, i-copy nyo and then paste nyo dito. Paste it here. Okay? So this is the code, yung library, read art, tapos yung wage na data name natin. You could have changed the name, of course, if you wanted. Tapos pinapakita dito kung saan ko linink yung data. Then automatic siya na view wage. Okay? So that's why may lumabas na ano dito na worksheet, andun yung wage data. So ano laman ng wage data? Education, experience, tenure, race, gender, civil status, number of dependents, and hourly wage. Okay, kindly chat please if you were able to download the wage data already. So that next time if you're going to run this, okay, andito na yung code. You don't have to import the data set again. Andito na siya. Okay, 3 have responded. Let's wait for your 2 classmates. So okay na, Samya, Ina, Payus, okay, Ina, Chard, nakuha mo na?
Yes, sir. Nag-error lang siya nung ano, wala
Sige,
daw
sige.
package ng reader.
We'll wait for you. Ha? Walang package ni ano? Ni read art?
Reader.
Okay, pag ganyan guys, you know what to do, di ba? Install, no?
Yes, sir.
Install kayo, no? Install that packages and then i-library nyo. Yung library guys, lalabas na yun pag in-import nyo dito. But you have to have, sorry, I forgot to tell you na this is a package kasi, so you should have been able to install it first. Okay na, Chard?
Yes, sir. Inaayos na lang yung code.
Okay, sige. Alright. So once you're able to download that, lalabas na yung wage data set. And how do we know that the wage data set is already loaded? Andito na siya, tingnan nyo sa data. Yan, wage with 526 observations and 8 variables. It's already loaded to your R machine. Okay, so let's now try to importante guys, maintindihan natin yung data natin. No? So we can do some study about our data, wage yung data na ginagamit natin. First is the structure. Let's see what the structure gives us. Yan. So the structure gives us, ang sabi dito, this is a table, no? This is a data frame, DF siya. Data frame siya. Remember, we studied the different structures of the data structures, and one of them is a data frame, and this is one of the most common ones that we're going to use for statistical analysis. There are 526 observations and 8 variables, 8 columns. And then you have the different, you have here the different variables. No? Ano daw yung mga variables dito? Andyan si education, si experience, they are all numeric. No? And then si race, andyan din, si gender, si civil status, but they're character variables. And then si number of dependents at saka si hourly wage, they're also numeric. So if we take a look at wage, guys, ayan, no? Si race, white, non-white, si gender, female, male, si civil status, single, married. Dalawa lang yata ito. All right. So another way to understand your data, kung ano yung laman niya, is to use the summary function. Okay, so summary, wage, let's see what this will give us. Yung summary, guys, it gives us the 6-number summary nga ito for your quantitative or numerical variables. So you have here your percentile 0, no? Yung minimum percentile 0 yan. This is your P25 or Q1. This is your P50 or Q2. And then you have your mean. And then Q3 quartile, third quartile. And then your Q4 or your maximum. Yeah, so it will give us the range, no? Minimum, maximum. So we know that the range of education is 18. Okay, kasi minimum minus maximum. And then ganun din sa experience, si tenure. Now, how about the categorical variables? Yung ano? Okay, take a look at race, gender, character variables sila. Okay, categorical. Character yung class nila. So binigay sa atin yung length nila and then character sila. Of course, you cannot compute for the number summary for categorical variables. Hindi natin pwede makompute yun. And then ganoon din sa number dependence and then hourly wage. Okay, so that's what the summary and the structure function gives us. Okay, now there are many other functionalities that we can use in order to generate your descriptive statistics. Number one, si psych package, no? Si psych package, meron siyang describe function. Ginagamit din to for descriptive statistics. So let's try to run that. Okay. Where is that? This one. Psych function. Okay. By the way, guys, tingnan nyo, naglagay ako dito ng psych, no? And then dalawang colon. This is to signify that this function describe comes from the psych package. And why do we sometimes need to do that? Kasi may mga functions na pareho sa ibang package. Kunyari, sa HMIS, no? May describe din siya. Descriptive statistics din yan. So, pag hindi natin sabihin, that might cause a confusion, lalo na kung na-load na natin yung mga packages na yan. Okay? So, psych, double colon, ibig sabihin from the psych package, we will use the describe function, describe wage. So, what do you get here? Okay, we can see here, guys, several statistical measures, descriptive stat measures. You have the number of the variable, then the count, 526. Ibig sabihin, walang missing value dito, guys. No missing value. Then you have the averages. Of course, guys, itong mga categorical na to, walang meaning yung ibang statistical measures, no? Walang meaning yung mean yan, yung standard deviation, kasi mga categorical yan. Median, wala. So, ang may mga meaning lang nito, guys, yung mga numerical. Okay, mean absolute deviation, minimum, maximum, the range, which is minimum minus maximum, maximum minus minimum, skew, kurtosis, okay, and then the standard error. Okay, now ang assumption, guys, is that you know what skew and kurtosis is, because you'll need that when you analyze your paper. Kailangan may discussion kayo on descriptive statistics. Okay, and also plotting. No? We'll include plotting in the next session. Okay, so this is what the site describe package gives us. How about yung HMIS, yung describe? Ano naman binibigay nito? Okay, iba din to, no? Okay, let's take a look at what HMIS gives us. Okay, isa-summarize na bawat variable. 8 variables, 526 observations. Okay, so si education. Ano sinasabi niya kay education? Ang count niya, 526, walang missing value. Guys, importante kung may missing value. Kasi if we compute for the mean, tapos may missing value, then mag-e-error yun. Mag-e-NA siya. So dapat walang missing value sa mga data natin. A distinct 18 different years of education. And then you have the mean. And I forgot what GMD is, guys. Sorry, nakalimutan ko yung... we can check anyway kung ano yung GMD dito. Geometric, ano ba to? Median, I'm not sure. Kasi malayo sa mean. So, I'm not sure if this is the median. And then, what's this? This is the 5th percentile. Yung panglimang observation. 5% na mga observations are lower than this observation 8. Okay, this is P10, P25, P50, P75, P90, and then P95. So mga percentile. And then we're given the lowest 5 values and the highest 5 values. Tapos bibigyan na siya ng frequency. No? Ilan yung zero education? If we go down here, ang pinakamaraming number of years in education is, ilan ba? Si 68. Hindi, ito 12. 198 of the respondents, guys, in the 526 respondents, 198 doon had 12 years of education, followed by 16, ito, 68, and then 14, etc. So it gives us a frequency tabulation of yung mga variables sa pwedeng bigyan ng usually mga integers, no? Kung hindi naman masyadong marami. Tapos mga hindi pa pwedeng mga continuous variable kasi mga decimals yun. Hindi siya pwedeng lagyan ng frequency distribution. Okay, then we have ganun din sa experience. Pero yung sa experience, guys, walang walang frequency tabulation. Kasi sa experience, ano ba to? Ano ba yung niya? Experience, tingnan nga natin. Hindi ba integer din to? Ganun din, di ba? Kasi malaki, may 44, no? Mahirap nang mahirap nang guys, i-categorize, no? Ano ba yung minimum ng minimum, asa yung minimum niya? May 0 siya, oh. May 0 sa experience, sa science, 44. Imagine, i-categorize mo siya kung ilan yung 0, ilan yung 1, hanggang ilan yung 44. It doesn't make sense anymore. Okay? So si si education, at least workable, 18. Okay, what about yung categorical variable natin, si race? Okay, 0 and distinct, dalawa lang, no? Non-white lang at saka white. So this tells us the frequency ng non-white 54, si white 472. So quite a good frequency tabulation already, no? Proportion 10%, ito 89%. Okay, ganoon din guys si gender. Okay, mas maraming male, medyo balance lang ng konti, 252 si female. Okay, also for your civil status, most are married, 60.8%, 39% yung single. Okay, ganoon din si number of dependents, guys. Ito may tabulation din, no? Kasi from 0 to 6 lang siya. 252 walang dependents. And then yung may 6 dependents, dalawa. So mostly walang dependent kasi marami rin yatang single, no? Dito yun. And then, saan ba yung yung may single ba at saka married? Let me see. Doon ba? Meron bang civil status? Ito, civil status. No? Marami rin kasing single, no? 206. So, of course, it doesn't mean na walang dependent sa mga yan. Pwede rin maraming dependent sila. Okay, but sa natin, sa distribution, okay, marami yung walang dependents. All right, so that gives us the describe using the HMISC. So pretty useful din, guys, no? Pretty useful itong describe na to. So iba yung mga binibigay nila. Okay, and then yung using scheme R, guys, yung scheme ng wage. Ito naman binibigay ni scheme R. So we have here the number of rows, 526 observations, 8 variables. So dinidefine niya ilan yung character dito, 3, ilan yung numeric, 5. May group variables ba? Wala. Tapos, and then, so ini-explain niya muna yung mga character variables. No? Si race, si gender, si civil status, ilan yung missing, okay, ilan yung empty, anong difference sa empty sa missing? Parang pareho lang. Number of unique, 2. A white space, I'm not sure what this is. But of course, guys, pwede nating tinan kung you're just a Google away, guys, to see what white space is in the scheme R package. Okay, so I will not go into that. Tapos ito naman yung 5 guys, 5 numerical variables. Okay, dito sa dulo nga meron siyang histogram, no? May histogram plot siya ng 5 variables na numerical. Okay, so yun yung scheme guys na scheme R na package using the scheme function. And then huli, itong paste text. Okay, we're using the stat.descriptive. Okay, so pareho lang ni Halos pareho lang ni psych na describe. Okay, ang difference lang ito, yung mga variables nasa columns, no? Education, andyan yung andito yung number of rows, number of values, number of null kung may 0, may NA ba, may mga missing ba, wala, etc. May minimum, maximum, etc. So quite the same. May mga nadagdag lang dito, no? May confidence interval of the mean at 95%. May standard deviation, may coefficient of variation. Okay, bakit NA itong mga to, guys? Kasi categorical variables. Okay, so that's what the paste text function does. No? Okay, let's go to this one. Okay, now we'll have examples of plotting. For example, we want to plot sandali, no? Dito pakitanggal muna, guys. Ito. Please remove this. Okay. Please remove yung wage, no? So we're going to plot education and hourly wage. Okay, saan si education and hourly wage? Dito sa wage yan. Education and hourly wage. Kasi gusto natin makita kung strong ba yung relationship nila. No? Is there a strong relationship between education and hourly wage? If we're going to use hourly wage as our dependent variable, which we will, so gagamitin natin dito si hourly wage in order to we will try to explain it using the other variables, education, number of dependents, etc. No? Okay, so let's